The universe is a massive place, and some of the largest clumps of matter in that massive place are stars. A star is a fixed luminous celestial body made of hydrogen and helium gas, whose mass is held together by its own gravity. Its energy is generated by incredible hydrogen to helium nuclear reactions. But the question is, how do stars come to be, and how are there so many different types of stars? Well, let's find out about the life cycle of your average star. All stars begin their life cycle either in stellar nebulas or nurseries, or giant molecular clouds called GMCs. Stellar nurseries and nebulas are where some stars are born, and they are mainly the remnants of other stellar explosions. Stellar nebulas are clouds of gas and dust lingering around in space. In order to begin to form stars, they must have a passing star's gravity pull on them to begin to clump mass of the gas and dust together. The gravity pulls all the matter to a central point, which is the center of the new star. If there is not enough gravity to perform nuclear fusion, a brown dwarf is formed. Otherwise, the 1.52 to the e plus 29 kilograms of mass, which is 80 times the mass of Jupiter, becomes what is called a protostar. A protostar is a star's second phase. Stars are only in this phase for a brief while, but while they are here, they are powered solely by their own gravitational contraction. Energy is transported from a protostar's core and photosphere through convection. Convection is the movement caused within a mass to tend to rise when it's hotter and less dense, and sink when it's cooler and more dense. Then the protostar begins to shrink, making its center more and more dense. As the star shrinks, its internal temperature increases and the star becomes opaque, so light cannot escape. The photosphere expands and the star enters its main sequence phase. Stars live the majority of their lives in the main sequence phase. Once a star achieves nuclear fusion, the star radiates energy and slowly contracts to compensate for this loss of energy. Once a star achieves nuclear fusion, the star radiates energy and slowly contracts to compensate for the loss of energy. The temperature at the center is rising because the star is radiating away energy but also contracting. The battle of gravity pulling in gas and pressure pushing out will continue through the star's entire life. The more massive the star, the shorter the main sequence phase is. Red dwarfs are thought to be immortal because of their incredibly small mass. Nuclear fusion continues to happen and the star never really dies. After the nuclear fusion is complete and all hydrogen has been converted to helium, the star begins to leave the main sequence phase. What happens to the star next depends on its mass. Stars with a 0.23 or lower solar mass automatically turn into a white dwarf. On the contrary, stars with solar masses up to 10 pass through a red giant phase. Some massive stars explode into supernovas or even collapse into black holes, taking the other stars and their binary systems with them. A supernova is the most energetic, explosive event known. Supernovas happen at the end of a star's lifetime. Its nuclear fuel is burnt out, and if the star is particularly massive, then its core will collapse. When this happens, a massive level of energy explodes, which will cause a blast wave that ejects the star's envelope into space. The result can be a neutron star, and many years later can be known as a radio pulsar. Black holes are produced from dying stars as well. A star with a mass 20 times larger than that of our sun has the chance to become a black hole. In the life cycle of a star, there is a constant war between gravity pulling in and pressure pushing out. The more massive the core, the greater the pressure. So when a star runs out of fuel and all of its hydrogen has been converted to helium, the pressure is so great the material in the core collapses in on it. The average star runs out of fuel and there are no more nuclear reactions to fight gravity. The electrons within a star eventually create enough pressure to stop further gravitational collapse, and that's when a white dwarf is created. It just cools and dies peacefully. Stars are some of the greatest mysteries in our universe. We can never really know for sure what will happen to a star at the end of its life cycle. They say our universe is 14 billion years old. How long will it take an Alpha Centauri, Sirius, or even our sun to come to the end of its life? Our sun will most likely expand into a red giant, and even at the end of this long phase, it will let out sporadic bursts of energy for millions or even billions of years. But the question is, could one of our neighbor stars possibly supernova and take us all with it? The answer is unknown. In the future, we have so much to discover. About 12 light years away, scientists have found a planet that is the size of Jupiter that possibly can sustain life. What will they find next? That is the question.